Okay, so here we're looking at our three-stage memory system with our sensory register over here. And then if we pay attention, information that's coming into our sensory system is able to go into the working memory system. And remember, that is also known as our short-term memory, right? So we can use the term working memory as sort of a descriptive term of what's happening inside of short-term memory. And if we elaborate and process on information, then we can encode it and it goes into long-term memory for storage. And if we are able to connect it well enough with existing information, existing knowledge through the process of elaboration, when we were thinking about it here in working memory, it's stored in a well-connected way over here, then we're able to retrieve it at a future date and remember it again. So let's take a look now at the processes that we see inside of working memory. So inside of working memory, we have the central executive, and that's sort of like the boss of these three other systems that it can recruit to do certain things for us. And the three systems are the visual spatial sketchpad, and we also have the phonological loop, as well as the episodic buffer. Episodic. So those are the three systems within working memory that our central executive here is able to direct and control.
So if we think about the phonological loop and the visual spatial sketchpad within short-term memory, doing all the work that's directed to them by the central executive, we can think about how we have these two systems that can help us remember stuff. And perhaps if we use both of them towards the goal of remembering something, it could be beneficial. So that gets us to what's called the dual code hypothesis. The idea is that some words benefit from being processed as a word as well as an image. And the part about it being some words is to distinguish between concrete versus abstract words. So abstract words in particular might benefit, or abstract images might benefit from having, a verbal label to make them a little bit more concrete. Because if we think about the level of processing study or level of processing demonstration that we did with Group A and Group B, we saw that if you have to think of a word's meaning and evaluate it, it might be helpful if the item that you're doing that with is concrete and refers to a particular object, as opposed to being an abstract concept. So if you're thinking about how helpful a boat might be if you're stranded on a deserted island, that can't be conjured up mentally. You can create this mental image. But if someone asks you, how beneficial would peace be if you're stranded on a deserted island, it's not quite as tangible. And while yes, certainly being peaceful or at peace would be beneficial, it doesn't seem quite as immediately sort of imaginable as a boat would be. And so there is this idea that we can remember things better if we can make them very concrete and make them something that we can visually, picture, or we can imagine in our minds. And so that's sort of the idea behind the dual code hypothesis. And so the study that we're going to look at had people look at these shapes here. So we can see, this shape here, and they have to, sort of remember it later on. But if they were given a label, pig in a fog, then this actually becomes kind of almost like a cute image where the fog is so thick that you can only see the pig's snout and you can't see the rest of his face, right? Without a label, it leaves this object relatively abstract and more prone then to making a mistake when you try and recall it. as opposed to when there is a verbal label. So that's the idea of the dual code hypothesis, that attaching a verbal label allows us to both process it as a picture, although an abstract picture, as well as phonologically here, and then creating this, sort of a auditory label as well. Now, a related concept has to do with, can we multitask then? So given that there are these different pieces, kind of different systems within working memory, can we use them together in certain ways to allow us to multitask? And so let's take a look at this particular study where participants were given a task to remember the chessboard. So we're looking here at the chessboard, and it's a chessboard at play, so it could certainly, it's a realistic setup for a chessboard with the pieces on it. And the participant, in addition to trying to remember where the pieces are laid out on the chessboard, they had to do one of these three things here on the right. So they were asked just to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Others were asked to type a pattern out with their hands. So while they were trying to remember the location of these different pieces on the chessboard, they were also typing a pattern that they were looking at and maybe required them to, sort of remember something like that and recreate it. And then a third group was asked to generate random numbers. So I want you to think a little bit and actually try and think about how these three different activities use the central executive, the phonological loop, and the visual spatial sketchpad. So counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We can do that very easily. It's fairly automatic, and so it doesn't require a lot of thought, planning, anything like that. And as a result, it probably just uses the phonological loop. In contrast, typing a pattern is going to require you to use up your visual spatial sketchpad, right, to create a memory of this visual image and then recreate it. Now think about the random numbers. What's that going to use? So it is, phonological in that you're saying the numbers, but it's really fundamentally different from counting, isn't it? So just take a moment and try and generate 10 different random numbers in your head, any 10 numbers between 1 and 100. Are you having to think about this a little bit as you try and generate these supposed random numbers? If you were like me, you may have started going in a sequence. So I did 12 and then I did 13 without thinking about it. And so I had to be very conscious on the next one to not just go 12, 13, 14. So if you think about how generating random numbers works, it's really using the central executive, right? So definitely using our friend here, the central executive. And so with this activity, with this experiment, we can see how each of these different activities might interfere with remembering the chessboard. And here are the results. The counting group had no trouble. They were able to do this just fine. The pattern group, they did not do well. They had a hard time with remembering both the pattern and the layout of the pieces on the chessboard. Likewise, the random number group had a hard time. They had a hard time generating random numbers at the same time that they were trying to remember this. And so the idea is that maybe counting was okay because counting does not use the central executive, does not use the visual spatial sketchpad, only uses the phonological loop, allowing the visual spatial sketchpad and the central executive to be occupied remembering the layout of the pieces on the chessboard. So it's the only one of the three that doesn't interfere. So can we multitask? The answer is yes, but it depends, right? We can multitask only when the two tasks we are doing do not require use of the same parts of working memory. So if we have a visual task plus a very, very familiar auditory task, that's fine, no interference. But we only have one central executive. It can't be trying to do two things. We only have one visual spatial sketchpad. It can't be trying to draw or imagine two different things. And we only have one phonological loop. It can't try and create two different melodies, for example. So that's an example of the limitations to multitasking. So yes, we can multitask, but only when the two things we're doing are really different and don't involve the use of the same components of working memory.